So our problem says a 75 milliliter solution of hydrogen chloride with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity calcium hydroxide. What was the concentration of hydrogen chloride in the original solution? So the first thing that we need to do is write out our chemical equation using our prior knowledge of how to create what your products are going to be from your reactants, and also you need to go ahead and balance that. So our final balanced chemical equation is going to be 2 moles of hydrogen chloride plus 1 mole of calcium hydroxide to 2 moles of water plus 1 mole of calcium chloride. So then we draw a picture. And so the picture I've drawn here, so it has, here we have your hydrogen chloride and the calcium hydroxide, and in the hydrogen chloride you can see that there's the particles are broken up and there's 2 moles of each. So basically what that means is that here there's 2, because there's 2 here, and then there's 1 of each here for this one. And then here we have the same thing, there's 2 waters, so 2, and then 1 of each for this 1 mole. And so basically also what I did was I went ahead and wrote what we're given. So here we're given 75 milliliters and we don't know our molarity, and here we're given 27.3 milliliters and we're given 0.157 molarity. So the next step you're going to do is find out what you know. So we know the equation volume times concentration equals moles, and that's going to help us for our solution. Okay, so the first thing you're going to want to do is change all your numbers that have milliliters to liters, and that's a very common mistake because it's easy to forget. So 0.0273 becomes your liters, and your new liters over here is going to be 0.075 because you just move the decimal place. So then here you're going to multiply your volume times your molarity, and here you're going to do the same thing, except you're not because you don't know what this is. So here when you multiply these two together, this is for calcium hydroxide, you're going to get 0.004286 moles of calcium hydroxide. And then another important step that a lot of people forget is that you have to do a mole to mole ratio to make sure you're going correctly from calcium hydroxide to hydrogen chloride, otherwise your numbers might be skewed. So you go back to your equation and you check your balanced moles, and so here you have 2 moles which you're going to put here and 1 mole which you're going to put here, and you put this one on the bottom because you want these to cancel. So by putting them on the bottom they will cancel, and then that will give you the correct number of moles for hydrogen chloride, because once again the question is asking what is the concentration of hydrogen chloride in the original solution. So once you find that number, you're going to come over here and you're going to divide it by the number of liters, because once again we know that volume times concentration equals moles. So if we're looking for concentration and we have volume in moles, then we just need to divide the moles by the liters, and that's going to give us our final answer of 0.1138 concentration or molarity of hydrogen chloride. And so this is our solution, and some common mistakes are forgetting to change milliliters to liters, so watch out for that, and also your mole to mole ratio.